Welcome to section 9.8, solving quadratic equations by completing the square. In this video, you're going to learn yet another form of solving equations, essentially finding those zeros, those roots, those solutions, those x-intercepts of a parabola. So we are finding exactly where a parabola crosses the x-axis. It can happen up to 2 times maximum. Okay, so you'll have maximum of 2 solutions for this situation. So let's get started. Completing the square is dealing with the whole concept of perfect square trinomials. We've been working with perfect square trinomials quite a bit when we were factoring and that sort of thing. We were dealing with situations where we had a squared plus 2ab plus b squared, and we could factor that into a plus b. Whoops, I wrote the wrong letter. We could write that into a plus b squared. We also had the situation where we had a squared minus 2ab plus b squared, and we can factor that into a minus b squared. So dealing with these perfect square trinomials, we can essentially see that there is a relationship between the coefficient of the x term and the constant term. So there is a relationship between this term right here and this term right here. And that relationship ends up being, if we look at that 6 and the 9 in our example problem, if we look at 6, we can say 6 is divided by 2. And then if we were to find that answer, we end up getting 3 out of it. And then if we were to square that, we end up with our constant 9. So that's kind of a neat relationship. And using that whole relationship, we can actually solve quadratic equations. It's kind of cool. So dealing with this perfect square trinomial, let's look at this whole concept. So we can use this relationship to help us find the zeros of a function when dealing with equations that are not perfect squares. So essentially, we can take an equation that is not currently a perfect square. It's potentially in the, looks like this, x squared plus 16x, and it equals 0 or 3 or whatever. And we can take that information and turn it into a perfect square by playing around with this special relationship that we find right here and turn it into a perfect square. So this whole process is called completing the square. So let's go and actually play around with this. To complete the square of x squared plus bx, we can add b divided by 2 squared, and that b we can take from our x term and divide it by 2 and square it. This will form a perfect square trinomial. So if we have x squared plus bx plus something we don't know, we can model that by taking our b term, dividing it by 2, squaring it, and adding it to the end. We can then take that b divided by 2 and we can say, oh, well, that is the information that we're actually going to put into our factored form, x plus b divided by 2, and that whole entire quantity is squared. These situations are equal. So now let's try a couple of problems with this whole concept. So our first practice problem, we are going to, actually I'll move it up to here. Our first practice problem, we have x squared plus 10x plus something we don't know. So we need to actually create that perfect square trinomial. So looking at what we had before, we had essentially, it was telling, or our equation is b divided by 2 squared. So it looks like we need to identify our b term. So our b term is equal to 10 in this case. Then after that, we're going to actually put it into this equation, put it into this formula, so it's just plug and chug. So if 10 is our b, we're going to put 10 in there, we're going to divide it by 2, and we're going to square that. So we get 10 divided by 2, which is 5, and then that squared is equal to 25. So at the end of our equation, we could say, instead of a question mark, we know that it is 25 if it's going to be a perfect square trinomial. We can also factor this, and it can factor into x plus our b divided by 2 term. We'll go right there, 5, and that quantity is squared. This can also be written as x plus 5 times x plus 5. And we can finish that up. I used the wrong color. There we go. So we can say that these are equal, and that's kind of fun. Let's try one more problem, and this one's a little bit more involved. So we have here x minus 9, or x squared minus 9x plus a number we don't know. So using that same concept, I'm going to zoom this in so we have a little bit more room. Using this same concept of that b divided by 2 squared. Our b term is this negative 9, so we can say that is negative 9 divided by 2 squared. So negative 9 divided by 2 squared is negative 4.5, or we could also leave it as a fraction and say negative 9 squared is positive 81, negative 9 squared, and then 2 squared is 4. So we can now put that into our equation. We can say 81 over 4 instead of that question mark. As well, oops, I didn't mean to do that. As well, we can take that and we can actually factor this and say it is x minus, because there's a minus here, x minus our original information here, 9 divided by 2, that whole quantity squared. This is our equation factored. So let's play around with this concept of a perfect square trinomial and actually find some solutions. So here we go. We're playing around with this whole idea. Solving quadratic equations by completing the square in 6 simple steps. I think this is the most amount of steps we've ever had, and completing the square is a little bit involved, so remembering these steps is going to be really helpful. So step number 1, we need to write the expression in the form x squared plus bx equals c. So perhaps we have the equation x squared plus 14x minus 15 is equal to 0. So we're going to need to actually make that switch and put the 15 over to the other side. So that's essentially what it's saying. So we'd need to see our equation looking like this. All right. If it doesn't look like that, then it's going to be really hard for us to complete the square. After that, we need to identify our b term, and we need to actually put our b term into this situation, b divided by 2 squared, and we need to find that quantity. That's going to be a number, and that number, step 3, gets added to both sides of the equation, not just one side, but both sides, so that way we can keep everything equal. So in this case, we have the 14. If we were to divide 14 by 2, we get 7, and we have 49 that we're going to then add to both sides. So we'd have x squared plus 14x plus 49 on one side, and on the other side we have 15 plus 49. Okay, so we're adding it to both sides, and that's really important. After that, we need to factor the perfect square trinomial. Our perfect square trinomial is this side right here with all the x's, so we could then factor that to x plus 7 squared, and then also solve this, which we get 64. And then we need to take the square root of both sides. So if we took the square root here, that square root cancels out the squared, so we just have x plus 7 on one side, and then we take the square root also of 64, and the square root of 64, if we remember right, is plus or minus 8, so there's 2 options there. That means there's 2 solutions. Last step, we need to write our 2 equations using both positive and negative square roots, positive and negative square roots, and solve each equation. So we'd have that x plus 7 is equal to a positive 8, and x plus 7 is equal to a negative 8. So we'd eventually find that x is equal to 1 and x is equal to negative 15. So these are both of our answers. We can see that there's 2 answers, so 2 solutions. That's the maximum we can have, and that's a good thing. So let's actually practice this with another problem so we can see this sort of figured out in a little bit simpler way. We have x squared minus 2x minus 2 is equal to 0. So our very first step that we need to take, our step number 1, is writing the expression in this form, x squared plus bx equals c. So it looks like our c term right here, this negative 2, needs to go over to the other side. And if we do that, we have x squared minus 2x is equal to a positive 2. All right, next thing, step number 2. Step number 2 is telling us we need to find b divided by 2 squared. And if we find b, there's our b term is equal to negative 2. We are going to take that term, I'm going to make it pink down here, negative 2 divided by 2, and we're going to square it. Negative 2 divided by 2 is a negative 1. And now we're going to square that quantity and we'll end up with a positive 1. So that is our amount that we're going to add to each side of our equation. We're going to add it to this side of the equation and we're going to add it to this side of the equation. So next step, step 3, actually adding it to each side of the equation. So let's rewrite our equation. We have x squared minus 2x is equal to 2. And so we're going to add this b squared b divided by 2 squared to each side. So we have x squared minus 2x. I'm going to leave a space right there for our new information that we're going to add, plus is equal to 2. We're going to add that new information, and here is the information we're going to add. We're just going to add a 1 to each side. So we've now completed the square by adding this b divided by 2 squared to both sides of the equation. Kind of cool. So now our next step, we need to factor this baby. We need to factor the perfect square trinomial. So we have x squared minus 2x plus 1 is equal to 2 plus 1, which is 3. If we're going to factor this, we're only going to be factoring this side right here, the x squared minus 2x plus 1. And if we remember, this plus 1 is essentially made up of negative 1 squared. So that negative 1 is what we're going to put into our perfect square trinomial. We'll have x minus 1 times x minus 1. And that is equal to 3. We can also rewrite that as saying x minus 1 squared. Make it nice and easy for ourselves, and that is equal to 3. Our next step, we need to take the square root of both sides, so we're going to take the square root of both sides. So if we take the square root of x minus 1 squared, the square root actually cancels out the squaring, so we just have x minus 1 on the left-hand side, and on the right-hand side we have the square root of 3. And the square root of 3, that 3 can't easily be broken down into square roots, so we're just going to leave it like that, but we're going to add positive or negative 3 because any square root is either positive or negative, because a positive or negative square root of 3 multiplied by itself will get us a positive 3 every single time, regardless of if it's positive or negative that's being multiplied. So we've taken the square root of both sides. We have x minus 1 is equal to positive or negative square root of 3. And our last little bit of our equation is the following. We need to write two equations using the positive and the negative square roots and solve each equation. So if we were to create one equation, we have x minus 1 is equal to a positive square root of 3, and we also have x minus 1, which is equal to a negative square root of 3. Last little bit of this is we need to solve each equation. So we're going to solve each equation by adding 1 to both sides. We're going to might as well do it on both of the equations so we just have them taken care of at one time. So this equation ends up being x is equal to 1 plus the square root of 3. And our other equation, we get x is equal to 1 minus the square root of 3. I should have done that in pink. Oh well, so here are our two answers. 1 plus the square root of 3, and 1 minus the square root of 3. I would like you to try your hand at the homework. Make sure you use your MISSIN to help you remember those steps 1, 2, 3, 4, 5, 6. And if you have any questions, be sure to ask them of me later. Thank you so much for listening and watching. Bye.